Hello Gearslutz, we're here at the Ginko Festival and I'm here with Sfefan from ACL.
I want to introduce you in some new modules because I'm from ACL, I forgot to say that. And I want to show you first the gate mix, which is basically a mixer, 4-to-1 mixer, subdivided into two 2-to-1 mixers with two sub outputs, with the aux input, which will be unity gain summed to the sum, and with nice switching features. And this I want to demonstrate you.
Okay, can you show it?
Okay, I will show it.
Yeah.
So I go on. So let's take a signal from a VCO and feed it to one input of the mixer, and the sum output we feed to the output. So now I have a switch here, and the switch is now switched off. You see that the LED is not lighting. When I switch it on, of course you hear the signal. So what's so special about it? The switch can be also operated by a gate signal. So now we got a beat step here, and now we feed the gate output to that input, and now when I press the button on the beat step, the sound will be heard. So it's not just switching on and off, it's doing a very, very short fade in and fade out all the time to avoid clicks when the signal is not just at zero crossing. So you get a very smooth switching in and out of the sound. And there's another nice feature. Now we can, while we had the gate connection established, now we can switch the channel on. And if we then apply a gate, it will be switched off. So it's like inverting the behavior or negating the behavior. Now I press and the sound is on. Now the sound is on, I press and the sound will be off. So gate high is meaning mute now, and gate high is meaning that the sound is there. What you can do with this is, for example, you can multiply the gate signal to the next input, feed another signal in the second input. Now we hear another oscillator, a sawtooth, and if I press now the button, oh, now it went off power here. Okay. If I press a button, it will swap the signals. Now we hear the sine wave from the one oscillator. Now we hear the sawtooth from the other oscillator. Or vice versa. So it can be also, the switching can be also done not just by gate signals. You can also feed an LFO, for example. The inputs are Schmitt trigger inputs, so they accept any signal, and above a certain threshold they will switch. Now I applied a LFO and it does the switching.
How fast can it go?
There's a limit because of the small ramps. We had to fiddle around a little bit with the right values of the capacitor, which does the ramp. I would say it's like about 10 to 15 milliseconds. So it's not that fast. So we had to make a compromise between being fast and hearing clicks all the time. So it's more for a performance that you can switch on channels, switch them off by a sequencer, but whatever. And then you will be fine having no clicks. Another nice thing is, if you take a closer look at the module, or maybe at the other one here next to it, because there's nothing connected yet, the input 1 and 2 is mixed to the output 1 and 2, so you get kind of submix from the channel 1 and 2 out of here, and same for channel 3 and channel 4, so you get a submix output. It's getting loose here on that output, and the sum of everything is coming out here. So you're flexible by, for example, you can now use it as a stereo mixer, 2-in-1 stereo mixer, by just using like 1 and 3 for one signal for the left channel, and 2 and 4 for the other signal for this and the other signal for the right channel. And also you got an aux input, which is also nice. It's just a unity gain input without any attenuator knob, which is directly going to the sum, so you can cascade several mixers or insert another signal from somewhere. So it's basically a fifth input which is not switched and not attenuated. Yeah, that's basically everything about that mixer. It's high quality op-amp based mixer, so nothing special about it. The nice feature is just the switching thing, and as we think, the arrangement with the submixes and the aux input, so yeah, quite flexible. I can also talk about the panning amplifier, which is basically 2 exponential VCAs. They are just exponential, they are not switchable to linear or something. The idea behind this was just to have like a stereo VCA. Of course, you can also use it as 2 separate individual mono VCAs. But the clue here is that you get a panning CV input, so you can of course make a panning with a panning knob. And if you make the panning, you will not have a hole in the middle. That means if you just have 2 VCAs, one is inverted controlled by the same CV than the other one, and you achieve a panning like that, you will always have a kind of drop of volume in the middle. So there's a circuit inside which provides like equal level panning. So it's like a panning law corrected panning. Then, of course, the VCAs can be used, of course, individually controlled by a control voltage. They can even amplify, so it's not just attenuating, so it can be even amplified to make sure that you will not clip. You have an overload LED here for each channel. And yeah, that's basically about it. And we have also an out interface, that's the third module I want to talk about, which is a very transparent interface in the way that it doesn't add any coloration to the sound, to the signal. It uses very high quality components, and it consists of two buses. One bus is converting a balanced signal from a studio. You can take a balanced signal from somewhere and convert it into a modular signal, of course stereo. And the other bus, it's exactly the opposite, so you convert a modular signal, stereo modular signal, to the balanced output to bind your modular system into a studio. And as I said, everything is very transparent, very high quality, low distortion, low noise. And there are some nice features about it. For example, the headphone output, which is also a very nice headphone output. It's a current amplifier, which is capable to drive headphones down to 16 ohm at full power. And it's also it has also no problems with higher impedance headphones like AKG studio headphones, like with more than 250 ohms or something. No problem. And as you might see, there's a switch here. IMO is standing here. I means the input bus. This is called the input bus. M stands for mute. So if the switch is in the middle, the signal will be muted. And out stands for the output bus. So you can listen with the headphone what's going on that bus. If you switch to the I position, you can mute it, or you switch to the O position, and then you will listen to what's going on here on that output bus. And there's also another feature, which is just the aux input. This is a stereo mini jack, so you can connect like an iPhone or something. And the same here, you can mix that signal which is coming here. It's going through an attenuator, so you can set the volume here of that signal, and you can have it muted in the middle. Again, the same principle like the headphone switch, or mix it to the input bus, or mix it to the output bus. So you're very flexible by using this with in certain situations, also for live or whatever. So even the headphone output is very high quality. The aux input's also very high quality. And yeah, I think it's a very good audio interface model.
You also have a power supply, right?
I also have a power supply. Maybe we can turn to that one. So it's here, just laid here on the table. And also the distribution board, which is supposed to be together with the power supply. So first about the power supply itself. This is a switching power supply, based power supply. Based means there are switching power supply blocks inside, but they will be linearly filtered by a very fast linear regulator, which is suppressing all spikes and crazy high frequency noises. And you get quite clean plus or minus 12 volts, up to 2 amperes each, with a ripple low at like 0.5 millivolts, and it's a randomly distributed noise. So I think it's negligible, and you will have no problems with either modules you want to use it. On top it has a 5 volts, but the 5 volts is not linearly filtered because it's supposed more to run for digital modules and stuff. So it can provide 2 amperes on minus 12, 2 amperes on plus 12, and 4 ampere on 5 volts. And also it's not very heavy, it has a very slim form factor, and it's also not getting very hot. So yeah, we'll be fine with that power supply, I think.
Nice quality material, right?
Yes, we use that Fisher enclosure stuff, that modular stuff here for that aluminium rail stuff. And yeah, we found it a good idea.
Rail, so you can mount it in a Eurorack, right?
No, you cannot mount it in a Eurorack. You can. It's basically meant for. If you look closer, you see there are 4 holes here.
Yeah.
So there are.
So you can mount it, no?
They can be mounted. There are 4 M4 nuts, like with windings for M4 screws. So you can just drill 4 holes. And then mount it wherever you want, drill another hole for that connector. In the future we will change that, the prototype, we will change it just for a simple round hole connector. But it's not, we are not sure yet how exactly we do it, because it might be even a little bit too overkill, too expensive maybe. But anyway, so, and the distribution board for that power supply, it's also special because it has not that typical daisy chain stripe shape. it's more like a star distribution shape, as you see already on the for the traces here on the PCB. So it means it distributes the power equally to all sides, and you still can cascade it. So in this system here we have 4 of these distribution boards, and you're very flexible also using it and also mounting it.
So for the people that don't know, what positive side is there to star ground? Can you explain shortly?
Okay, star ground means that from one point of the power supply, the ground wire is distributed evenly to all destinations where it's needed, instead of just going to one wire, and from there it's like daisy chained, like providing the power to all the modules. So the advantage is, for example, imagine if you have like a stripe style distribution board. If you have like the power coming from one side, and on the last connector, imagine there's like a very consuming module, you might have even a voltage drop already between the first connector, which is closest to the power supply input, and the last connector, where the heavy consuming module is connected to. So you might have even like a voltage drop there because of the resistance of the stripes, of the traces, and that might lead you into problems sometimes. So this is basically, electrically, it's the best way to achieve a power distribution. So we try to approximate it as much as possible,
right,
using that topology.
Right.
So in the end, it will be, if you use several of those boards, in the end it's of course not a true star power distribution anymore, but you still will be very close. It kind of turns to say tree power distribution. So it's still better than just having like one bus going through everything, and the last module is not getting as much maybe anymore as the first module.
Right. Okay, cool. Thank you very much. Any plans for the future?
Yeah, there are some plans for the future. Is a module which will come very soon. It's like already in production. This will be a new type ladder filter. It's based around the classical Moog ladder core, but everything else, all the amplifiers, the buffers and everything is completely new developed. And it has also some nice features. Maybe I can tell some features already. For example, Moog filter, when you have like a higher resonance, the bass will drop. It will turn into a bandpass behavior a little bit. So you have a makeup knob, so you can again get the bass back.
Okay.
Moog filter originally is like that the resonance is dependent from the cutoff. That means you turn it into self-oscillation, you go down with the cutoff, at some point it will stop. So that's kind of high-pass behavior inside of the feedback loop for the resonance inside of the filter. And there's a switch on that module, so you can have that original behavior or don't. So you can even go down with self-oscillation to 0.5 Hertz. Then you have like outputs for each stage, like 6 dB, 12 dB, 18 dB, and of course 24 dB. Then you have voltage-controlled resonance with a logarithmic converter behind, so you can very smoothly control the resonance also by voltage. And you got an input mixer for 3 input signals. You got 2 attenuated CV inputs. A third is not attenuated, so it behaves a Waldberg TAF. And it's also tracking astoundingly well for a ladder filter. It's like minimum tracking like 5-6 octaves quite well, and because it's everything temperature stabilized, you can also use it like as a sine wave LFO. Because of the low distortion amplifier structure inside of there, you get a very pure sine wave. Like it's really unbelievable, and a spectrum analyzer just one line. We got it like this, and if you still saturate the filter by overdriving it with input signals, you get a very nice distortion. You get basically second harmonics, a little bit third, but it's like a very warm sounding distortion.
Cool. Okay, cool. prices and availability?
Prices are not yet available, but they will be announced soon, of course.
Oh, okay. Okay, thank you very much from the Gearslutz, and I hope you enjoyed the Hague. Thank you very much.
Thank you too. Bye bye.